Welcome back. This is Algebra 1 Honors with Mrs. Rubright. Today's lesson is 8.2, Characteristics of Quadratic Functions. Alright, so graphing functions in the form of g of x equals x squared plus k. This is the same thing as y equals x squared plus just a number. Okay? Graph each quadratic function. The graph of the parent function f of x equals x squared. So y equals x squared is your parent function, okay? And they want you to graph this new function. So f of x, or g of x, right? So it's y equals x squared plus 2. So if I plug it in as 0, I'd have 0 plus 2 or 2. If I plugged in a 1, I have 1 plus 2 or 3. If I plug in a 2, 2 squared is 4, 4 plus 2 is 6, 3 squared is 9, 9 plus 2 is 11. Negative 1 squared is 1, 1 plus 2 is 3. Negative 2 squared is 4, 4 plus 2 is 6. And negative 3 squared is 9, 9 plus 2 is 11. So you guys see this nice little mirroring going on here. 3, 3, 6, 6, 11, 11. All right, so let's plot these points. So we have 0, 2, negative 1, 3, 1, 3, negative 2, 6, and 2, 6. 3, 11, negative 3, 11. So this is our graph. Do you guys notice anything about this graph compared to the parent function? What's going on here? Our vertex used to be at 0, 0, now it's at 0, 2. You guys see how it's shifted up 2? So when you have a plus off to the side, this is saying it's a vertical shift of up 2. It's being vertically shifted up 2. So what do you think this one's going to be before I even graph it? It's going to be a vertical shift of down 2. It shifts down 2. So if I just looked at my graph right now, instead of 0, 0, it's going to be at 0, negative 2. Instead of 1, 1, it's going to be at 1, negative 1. Down 1, 2. Instead of 2, 4, down 1, 2, 2, 2. So this is what it's going to be just based on knowing my parent function. But I'm still going to actually come up with these points by plugging and chugging and verifying that this is correct. If I plug in a 0, 0 squared is 0, 0 minus 2 is negative 2. 0, negative 2, there's our point. If I plugged in a 1, 1 squared is 1, 1 minus 2 is negative 1. Do I have 1, negative 1? I do, and I have negative 1, negative 1. If I plug in a 2, 2 squared is 4, 4 minus 2 is 2. Negative 2 squared is also 4, 4 minus 2 is 2. So I have that 2, 2, and that negative 2, 2. If I plug in a 3, I get 9, 9 minus 2 is 7. Negative 3 also gives me 9, 9 minus 2 is 7. So I have 3, 7. And negative 3, 7. So it would continue. Is this making sense, guys? You see how it just shifted down 2. You take your original parent function, just shift all your points down 2. How is the graph f of g of x equals x squared plus 2 related to the parent function? It's shifted up 2. And it's a vertical translation of up 2. If I have x squared minus 2 compared to x squared, that is going to be a vertical shift of down 2. In general, how does the graph g of x equals x squared plus k relate to the graph of the parent function y equals x squared? It's just going to be shifted up or down. Shifted, vertically shifted up or down by k. Vertically shifted up or down by k. Okay. So, graph the quadratic function. The graph of the parent function, f of x equals x squared, is shown in gray. All right, so now if I'm going to do this, Do you guys see how now if that negative 1 is not on the outside, it's not x squared minus 1, it's x minus 1 squared. When it's inside like this, it is not going to be a vertical shift, but it's going to be a horizontal shift. So let's see what goes on. If I plot these points. So how about I plot -2, -1, 0, 1, and 2. I guess I can keep going. 3 and 4. Sure. All right. So if I plug in a 0, 0 minus 1 is -1, -1 squared is 1. If I plug in a 1, 1 minus 1 is 0, 0 squared is 0. Same thing for -1 minus 1 is -2. -2 squared is 4. -2 minus 1 is -3. -3 squared is 9. 2 minus 1 is 1. 1 squared is 1. 3 minus 1 is 2. 2 squared is 4. 4 minus 1 is 3. 3 squared is 9. All right, so I would have 1, 0, 2, 1, 3, 4, 4, 9, 0, 1, -1, 4, -2, 9. So what happened to my graph? Anybody? Yes. To the right. So it shifted 1 to the right. It's horizontally shifted 1 to the right. So when it's on the inside of the parentheses, it's left or right opposite of what you would think. So you're shifting in the positive direction 1, right 1. Which means that this one's going to shift what? Left 1. You take all these points and you go left 1, left 1, left 1. And this is what it should look like. So if I'm shifting left 1, my vertex, my middle point, right, your vertex, is going to be at -1, 0. So I'm going to go on both sides. So -1, -2, -3, -4, 0, 1, 2. So that's how I know which points to plot, right? I know based on my shift where my vertex should be. So if I plug in a -1, -1 plus 1 is 0, 0 squared is 0, it checks out. 0 plus 1 is 1, 1 squared is 1, 1 plus 1 is 2, 2 squared is 4, 2 plus 1 is 3, 3 squared is 9. -2 plus 1 is -1, -1 squared is 1. -3 plus 1 is -2, -2 squared is 4. -4 plus 1 is -3, -3 squared is 9. You have that nice mirroring going on, and those points are the points that I graphed, that I already put on the graph, so I know that I am good. I know that I graphed this appropriately. How is the graph related to the parent function? So with the minus, it shifted right 3. I'm sorry, it shifted right 1. And then this shifted in the negative direction 1, which is left 1. How is the graph related to the graph of the parent function? It's going to be a horizontal shift by h, right? Horizontal shift left or right by h. So if h is greater than 0, if it's positive, it's getting shifted to the what? Left. And h is less than 0. If it's negative, it shifts right. Right? If it's negative, it shifts right. If it's positive, it shifts left. Like over here, if it was positive, if k is greater than 0, it's up. And if k was less than 0, it's down. Right? If it's negative, it was shifted down. If it was positive, it was shifted up. If it's negative, it's shifted to the right. If it's positive, it's shifted to the left. Right? It's inside the parentheses, it's opposite of what you would think. Write the equation for the quadratic function whose graph is shown. Okay. So our vertex would have been at 0, 0, and instead it's shifted 1, 2, 3 to the right, up 1, 2. Right 3, up 2. Is it following the same pattern, or is it vertically stretched or shrunk? Let's see. Over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4. It's following the normal pattern of over 1, up 1, and over 1, up 4, right? Because 2, 4, 1, 1, right? So we know it's not vertically stretched or shrunk. It's literally just shifted right 3, up 2. So right 3, up 2. Let's think about that. So the right 3 is going to be inside, and then the up 2 is plus 2, right? So right 3, opposite of what you think, negative 3, right? Negative is right. Even though you're going in the positive direction, we call it negative 3. So this would be y equals that. We're going 3, 2, to the right, up. So h is 3, k is 2. The equation is g of x equals x minus 3 squared plus 2. So what can you do to check if your equation is correct? Plug and chug some problem. Plug some points in, right? So let's plug in 3, 2. Does 3, 2 work? 3 minus 3 is 0. 0 squared is 0. Plus 2 is 2. How about 4? I better get 1. 4 minus 3 is 1. 1 squared is 1. 1 plus 2 is 3. Did I say 1? I meant 3, right? Because 4, 3. If I plug in, say, 5. 5 minus 3 is 2. 2 squared is 4. 4 plus 2 is 6. 5, 6. They check out. So we know we didn't mess anything up. All right, so let's go down to some practice. So if we're doing this one, we're shifting what? Up 4. So if I have my normal parent function, would be 0, 0. Instead of 0, 0, it's 0, 1, 2, 3, 4. Then it's over 1, up 1, over 2, up 1, 2, 3, 4. Right? That's how it normally would be. Because you normally would have 1, 1. You'd have 0, 0, 1, 1, negative 1, 1. You'd have 2 squared is 4. So here's your parent function. This is y equals x squared. And this is everything being just shifted up 4 each. Does that make sense? You can plot points. You can do an XY table, plug and chug. That's totally allowed. Or you can just take your parent function and apply what you're doing. So here, this is going to be right 2. So if I take my parent function of 0, 0, 1, 1, negative 1, 1, 2, 4. So this is the parent function. This is y equals x squared. If I apply this to it, I'm going right 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. This is shifted right 2. This is your f of x equals x minus 2 squared. So the answer is that one. Make sense? Do you guys see how I did that? I did the parent function and then I did that. You can also do your XY table. You know that your vertex was shifted 2 over, so it should be at 2, 0. And then you could do 1, 0, 3, 4, 2 on each side, and plug and chug. If I plugged in a 0, I'd have negative 2 squared, which is 4. 1 minus 2 is negative 1. Negative 1 squared is 1. 3 minus 2 is 1. 1 squared is 1. 4 minus 2 is 2. 2 squared is 4. And those are the points that I graphed, just based on the fact that I know that it was shifted right 2. What if they gave it to us where they did multiple things? So right here, this would be what? Left 4, up 3. So my vertex should be left 4, 1, 2, 3, 4, up 1, 2, 3. So I can do my vertex. I can do an XY table if I want. Left 4, negative 4, 3 is my vertex. Let's double check. That'd be 0 plus 3 is 3. It works. Negative 5, negative 6, negative 3, negative 2. All right, it should be over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4. So I know what it should look like, but let's just show you. Negative 3 plus 4 is 1. 1 squared is 1. 1 plus 3 is 4. So negative 1, 2, 3, 1, 2, 3, 4. Checks out. Negative 5 plus 4 is negative 1. Negative 1 squared is 1. 1 plus 3 is 4. Negative 2 plus 4 is 2. 2 squared is 4. 5, 6, 7. So that's the points that you should have, and you plot them. And then our last one for today. This one is shifted 1, 2 to the right, right 2, down 3. So right 2, down 3. So this is going to be g of x equals x minus 2 minus squared minus 3. Let's double check if this works. Let's plug in some points. Is this over 1, up 1, over 1, up 1, over 2, on 2, 3, 4? Okay, so 0, comma 1. 0 would give you 4 minus 3 is 1. It works. If I did 1, I should get negative 2. 1 minus 2 is negative 1. Negative 1 squared is 1. 1 minus 3 is negative 2. It works. Is that making sense, guys? Do you guys see how you come up with the equation? So your homework tonight, you guys are going to practice page 425 and 426 in your workbook. 425 and 426. I hope you guys enjoyed today's lesson. Please like and subscribe and have a fantastic day.